So our next speaker is Danny Shorten, and he's been in the industry for a lifetime. He's currently heavily involved with John Crane in the development of asset condition maintenance, monitoring, managing for critical rotating equipment. Danny's also been awarded a prize from BINDT for comedy, and this is for his contributions to society via condition monitoring, predominantly in the marine sector. Danny's been working with BINDT, UK standards and the ISO on a soon-to-be-released certification for asset condition management specialists. So if anyone's got any questions on that, Danny is your person to speak to. Today, Danny's going to help us explore the merits of condition-based lubrication. Thank you for joining us, Danny. We can see your presentation and your 20 minutes start now.
Thank you very much, Jade. I appreciate it. And thank you very much to Adam for framing what we all like to see, which is a fully understood oil analysis suite. What I'm going to talk about today is possibly those assets where we don't necessarily do oil analysis, and therefore we don't necessarily have an understanding of the asset condition within the system. Now, in a recent survey, 90% of people, when questioned, agreed that lubrication was critical, but only 30% of those suggested that they are actually achieving acceptable performance. Now, this was recently highlighted on a webinar which Rafe performed recently. For those in the community who get on social media, you'll know Rafe is very knowledgeable and has a broad understanding. And he suggested one of the things we need to do within most companies is identify a champion who owns all the areas of lubrication. Not necessarily that he or she is responsible for performing the activity, but so there's a degree of oversight, someone who can be consulted and who can actually fight for good practice and behaviour. Simply because we believe that the gap between the 90% who believe it's critical and the 30% who believe they're achieving a good standard is likely due to prioritization, because we're very much focused on performance of production, or getting the products out, or maintaining and fixing failures. Now, we have a proliferation of maintenance management activities. We have sensors. They've got the opening dialogue with AI. We use labs. There's the opportunity for on-site mini labs and portable devices to create a matrix of capabilities to allow optimal risk management. Now, my message really is best practice is all well and good, and we need to know what it is, but good enough is good enough. And most companies don't really understand where they are on that particular paradigm or that continuum. They will be used to doing it a particular way, and they will be accepting a certain amount of risk, either knowledgeably or otherwise. So one of the messages today is, how can we actually increase our knowledge? Now, my company, John Crane, is involved with the manufacture of high-end mechanical seals, filtration products, couplings and bearing isolators, and we operate in most countries, and in the majority we're in large process and petrochem, where we've got large significant asset bases. Now, we realise that many of our products are often changed out earlier than we would have liked because of their design requirement, but very often this is a result of a no-fault situation or an opportunity that's presented itself because a bearing has gone down or we've had misalignment due to external factors. So this is why understanding machine condition is critical to us. Now, on the screen you'll see John Crane Performance Plus window, and the area I'm involved in is asset condition management, and this really frames the discussion we're going to have today over the next 20 minutes. Now, the core problem, I think, is that we spend a lot of time doing stuff we don't necessarily need to do. We do stuff that doesn't impact asset health, and we're changing oils, for instance, when they don't need to be changed, and in doing so we're introducing interventions that introduce avoidable risk. We're also having to stop plant or go on to AB or increase issues around safety because we're getting the tools out of the box and we're actually going on plant to do stuff which may or may not be necessary. So we're consuming maintenance capacity and the consumables, but we're not really aware of whether that's necessary or not. However, doing something often feels better than doing nothing, and I'm going to argue the case that actually doing nothing sometimes is actually better than doing something. Now, when we look at a sort of medium-sized site, the calendar structure would normally look like this. So if you've had an oil survey or you've updated your maintenance management processes recently, you'll be doing oil analysis on probably your critical items. And these will tend to be driven by the sump size, i.e. the ones with the most oil in, or the criticality to operation. And you'll be sampling them on a monthly or quarterly basis. The smaller systems, where you are not really happy to make a commercial decision to take an oil sample, box it off, send it to a laboratory 4 times a year or 12 times a year, these will be on some kind of fixed schedule. Nominally, 3-year oil change and an inspection process for top-ups. Your grease systems will be visited according to a calendar schedule. Somebody will walk a line with a grease gun and they will apply grease according to that schedule. So the truth of the matter is, let's say in this example we've got 250 lubricated sumps, only 10% of those are going to be sampled, so you've only got knowledge of the internal condition of the oil and the machine in 10% of those assets. So 225 are unknown commodities. Now we can inspect from the outside, we can have a look for leaks, we can do all sorts of stuff, but we don't really know what the condition of the oil is, so we're going to change it based on a calendar basis. So 225 oil changes we're going to do whether we need to or not. And that equates to about 75 oil changes annually. So that's more than 1 a week if you spread it out. And in addition, everything is greased whether it needs to be or not. And that leads to a problem because we can under and over grease systems and we may or may not know what we're doing. So can we do it differently? This is the question I want to ask everybody. Can the oil be changed or a system re-greased only when it's necessary? Well, the answer is of course yes, but there's a commercial consideration as to how we achieve that knowledge. So if we know that the oil is unsuitable for further service, then we'll change it. But if it's okay, we can leave it, but we need that knowledge. If we know it's contaminated beyond repair, so it's something a filtration system can't deal with, then we can change it and we can clean it. But if it's clean, just leave it. If the oil is degraded, same thing. Change it or leave it. But if we can prove that we don't need to do it, then we can leave it. And it's not negligent, it's an active decision. So we're actually changing something from a scheduled activity to a decision window. Now the sort of things that we can do on site, for instance, because the solution is to test on site, is to look for the issues Adam was talking about earlier. Is it the right oil? Is it wet? Is it dirty? Has it aged? And there are on-site tests we can do for that. We're not concerned here about machine condition, we're simply interested in the condition of the oil. Can we leave it there or do we need to change it? So I'm not really interested at this stage in wear metals. If I was, I would send it to a laboratory or I'd build a mini lab on site to do that, but this is not the purpose of the discussion today. Similarly with additive depletion, we're not really looking at that, although there are some devices that can help us. So what tools are available? Now this of course depends on the commercial argument for doing on-site analysis. So we can do simple things with water, such as a crackle test. We can do more involved testing using, for instance, the Spectro Fluid Scan handheld IR, which is quite a high value asset, but gives us a lot of information around the condition of the oil. So that can produce a go or no go, but there are costs involved there. We can do patch testing where we actually take an oil sample and provide a filter patch, and we can use microscopy. And there are other devices which can look at relative contamination, oxidation. There are field tests for tan, for water, etc., etc. Now I'm not going to get into the solutions here, but there are many opportunities and options to do this. Now what my view is here, because we've got a massive proliferation of sensors, we're using AI, We can use an off-site laboratory, and I certainly wouldn't suggest moving away from that. We can also do stuff on site as well, and we can gain knowledge about our equipment, even if it's very basic knowledge. We take a very small sample and we do some kind of qualitative assessment. This is good sense. So we're managing the risk and not just ignoring it. So any system managed by a calendar leads to unknowns and represents a risk. I recently went to a company and they said, we don't change oils. We don't have problems with gearbox failures. And when we dug a bit deeper, they were just used to doing refurbishments at a frequency which I would have considered to be excessive. But that was business as usual for those guys. So you may or may not know you've got an issue that you can improve on. And we tend to manage risks we're aware of by over-maintaining. And in doing so, we introduce more risk. And if we take a component out of service to do something to it, we put it back into service, we actually create a new infant. And therefore, because it's now a new asset, we're introducing a new risk because it's further down what we call the PF curve, where the potential for failure is increasing simply because we've actually taken it apart and put it back together. So the argument here is working smarter, not harder, and certainly not deferring without any understanding of risk. So we need to have the knowledge in order to make the decision. Now, we've done some work on a number of sites, and we can report quite confidently that there's likely between a 10 and 30% reduction in oil consumption, which at the moment is quite a critical thing to talk about based upon what's going on in the world and the knowledge that we're going to have supply issues, not only from the base oil and the refineries, but some of the finished products are going to be hard to get. And you'll probably have seen some messaging from any distributors or oil companies to say that pricing is going to be impacted. But we're also going to see potentially a reduction, and quite a significant reduction, in the lubricate-related work orders, i.e. stuff we do because it's in the schedule, but we could argue we probably don't need to do it. And therefore, if we're not getting involved with those assets, we've got fewer contamination-related failures, and we've got actually more likely that we're going to adhere to the schedule because we're going to be doing stuff which is relevant. So why does this matter? Well, the standards of our operations influence behaviour. And if anybody's ever done an assessment of any company's lubrication management, they will be very soon realise that it's the culture of lubrication which is often at the fault. Not necessarily individual fault, it's a corporate culture around lubrication management where it's been effectively flattened and forgotten about, and it's assumed to be running within reason. So what we have to do is we have to make sure that we don't see task deferral, i.e. delaying maintenance, as some kind of form of negligence. We can defer if we have the knowledge. We have to improve the reputation of lubrication and see it as good engineering practice, not just something we have to do which is given to those within the organisation with the least training and the least skill. We have to extend intervals with technical justification, and we have to make oil changes based upon the critical needs of the asset, not the need of the schedule, because the schedule is simply there as a smoothing tool and very often leads to greater levels of work. So why does this matter? Well, if you're using fixed time-based intervals, there is no relevance to the need of the asset. This is simply a tool to make work planning easier. It doesn't necessarily give you any value. If we're looking at OEM guidance, for instance, when you look at the handbook, they'll say perform an oil change every 70 miles or 70 hours or whatever. And I would argue that if you're taking an industrial gearbox, the amount of potential context that gearbox can be put into is going to be much more significant than the handbook's going to really relate to. So the handbook, in many ways, protects the manufacturer from negligence because it can hold its hands up during warranty and say, you didn't follow our instructions. But out of warranty, it has no value. So actually maintaining the condition of the oil is very much relevant to your operation and your condition, and that may mean changing it more frequently or actually less frequently. The problem with schedules, again, it's very much focused on convenience. It's about the planning aspect, not necessarily the needs of the asset. And when you have something which is not based on the needs of the asset, schedule compliance, which is very often a metric that we use to measure how good we are, has no relationship to the reliability. It means you've done something, but it doesn't necessarily mean you've gained any benefit. And these, I think one would argue, historically were very sound views, but this now is changing because we can access more knowledge and have the ability to make better decisions. So what costs happen? Well, we have to pay for labour, we have to take the asset out of commission, we've got to manage any spills and contamination, we've got to expose individuals to health and safety issues, we've got waste, we've got potential errors due to human errors and perhaps training issues. And of course, we're now focused on work that is not rewarding us. We're focused on work which is simply a schedule compliance task, creating unnecessary work, unnecessary costs, and unnecessary risk. So instead of seeing an oil change interval, why not make it a decision window? This puts the power back into the engineer and the reliability management in actually to do something that adds value, or to avoid it in the knowledge that risk is still being managed. So when we're using a decision window, when we get to the prize, we can define the acceptance limits and alarms for every system. We make decisions based on evidence as opposed to simply because it's time to do something, because it's the 4th of June and that's what we do on the 4th of June. We've got a clear authority to defer and extend oil change interval with time and date stamp verification of status, which gives us a feedback loop to confirm these decisions are safe. And we have confident knowledge of condition. Now, one real-world example, which I can quote, was a large refinery over in the States, and they were very diligent in doing their oil changes. And the scale of it, as you can see, was quite significant. And what they did a cost analysis by using the spectrofluid scan device, which allowed them to visit each sump, take a very small drop of oil and assess the oil condition, go, no go, etc. And in the first year of the trial, they actively identified that 90% of the systems did not require oil change. Now, over time, that number will drop because oil will require changing at some stage. But they actually avoided oil change on over 2,000 systems. And their calculation, not mine, was actually quite significant in terms of the first year. And they recovered their capital investment also quite quickly in that period of time. Now, noting that that capital is probably going to need replacing in 5 years, they've got 4 years of access with the only cost being actually taking the sample. Their prediction long term is to permanently eliminate 50% of the previously scheduled oil changes through a condition-based decision making with appropriate risk management. And they are now mapping this out to other sites. Now, admittedly, this is a large group of assets and that may not be relevant for everywhere. But the process suggests that at least we should ask the question, is there an opportunity to move maybe not all of the assets you don't put in an oil condition monitoring program, but some more assets into that so we can avoid unnecessary oil changes. So I'm coming to the end of my 20 minutes. My key takeaways are schedule oil change feels safe, but they add cost, and we can see that cost can be quite considerable. Condition data, if we can acquire it and trend it, adds a degree of certainty to our decision-making processes. And this new activity does not necessarily require any significant training or upskilling. We use very competent people generally, and giving them the skills and awareness to take lubrication to another level is quite straightforward, so long as it's built into the culture. So we also get value from avoided work, the risk reduction, and the added assurance that we are actually working based on data and intelligence. And as you've seen, the value can be significant for medium to large size asset populations. And that end my discussion today, and I thank you very much for your attention. Please, if there are any questions, we'll get round to it in the panel at the end. But for now, thank you.
Thank you, Danny. You have had a question come through, so I've made a note for that for later on. Condition-based lubrication is something which people are adopting more across all industries, and as you've shown, sometimes doing too much can cause problems, even in the smallest of oil or grease reservoirs. Understanding the condition is invaluable for improved reliability and sustainability, especially in this time of worry with lubricant supply. We certainly don't want to be changing oils and greases just because.